I am Clinton Garwood, and in this presentation, MapReduce will be introduced. MapReduce is a programming paradigm that allows massive data sets, which are often saved in a distributed file system architecture, to be analyzed at a very granular level. In addition to this presentation, please find a fully documented research paper provided as an appendix. MapReduce was first documented as an industry standard in 1995 and named MPI-2. At its core, MapReduce is a concept to break down the workflow of a programming solution into multiple smaller chained processes. A number of factors delayed market implementation of this technology, and then, nearly a decade after the industry standard was described, Google published a MapReduce paper which introduced a simple Hello World starter code sample that renewed interest in the idea. 5 years later, interest had swelled to a point that design patterns, which are something akin to recipes, had been identified for several major use cases. This presentation will look at three, namely data summary patterns, data filtering, and data transformation MapReduce design patterns. A data summary MapReduce design pattern takes the concept of applying a mathematical function, typically addition, subtraction, multiplication, or division, but might also include computing an average to every node of data found in the data set. The design pattern, as it's illustrated here, first breaks the data down into multiple chunks. And this is the mapping stage, and unique characteristics of data are identified as key value pairs. The partitioner here is primarily designed to handle workflow and the physical file system, like a Hadoop distributed file system, as the job is run. Finally, the reducer in this case summarizes the results of the computation. The Hello World application mentioned earlier is designed to run a word count over a document or a book. In fact, the full-text book of War and Peace by Leo Tolstoy is included with the Apache Hadoop and can be run to verify a properly installed Hadoop installation. Next, we'll look at the design pattern called filtering, or the filtering design pattern. In this pattern, the concept is to ask for each node in a data set, is it true or false, as compared to the computational question. Also known as the search function for MapReduce, this design pattern can be run without a traditional reduce function, which makes this pattern often very fast and efficient. We see here in this diagram the input split being a location of each piece of data in a set, fed to the filter mapper, which identifies true or false label for each data node. If a data node is identified as true, for example, we pipe that node to the output split, and conversely, if it's false, we simply can discard that piece of data. In this example, we see a top 10 design pattern, which is still mapping true or false to the data, but which also adds a reducer function. The top 10 reducer, shown in the diagram, summarizes and sorts the true data into the organized final list. This filtering pattern is common for recommender systems, which people often find in services like Netflix. In fact, Netflix is famous for running a $1 million contest where design teams were invited to make an improvement over its proprietary system. The contest ran for years, and the prize was eventually awarded to a design team which was composed of a variety of industry professionals. The winning algorithm made use of two distinct styles of filtering known as collaborative and context filtering, which you can read more about in the attached research paper. Finally, we'll look at the data transformation design pattern. Like it sounds, this design pattern takes data of one set and transposes it into data of a different set. The data set is really what is unique here, and it is not like a simple cast of an integer to a float, but is most often used to take an entire database in one format and transpose it to a database in a different format. What we see in the diagram here is The reduce pattern is re-schemifying data, which is often going to be re-encoded, reclassified, and otherwise reorganized into a format that will be used in a new and unique way. The case study that we'll look at for this one is Zillow using Amazon Web Services to take millions of points of data from a transaction-style data collection system and transform it into an online analytics data warehouse system. The intent of this project was to process the otherwise initially unconnected data into market insight and knowledge. Again, please look to the research paper for more details on how this was accomplished. In summary, MapReduce is a programming paradigm that allows programmers to analyze massive data sets in useful and unique ways. The use of MapReduce has been accelerated by the concept of design patterns, of which we looked at 3, both from a workflow architecture and also at real-world case studies which have implemented the concepts. I hope this presentation has been helpful in understanding the basic concept and how the technology is used. Thank you.